Hello, everybody, and welcome to the IFW Show. So, I am your host for today, Karan Garg, and inviting you all and welcoming you all to this week's show. It's a very interesting show that we have lined up for you, and it's on a very interesting technology which is claiming to change the world as we are speaking. It's already a very popular technology. It's about 3D printing that we are going to talk about today. We have a very interesting personality to speak about this topic who is doing amazing work with his team on this technology of 3D printing, and they are developing amazing applications right now and helping a lot of people with this technology. So आज हम इस पे बहुत डिटेल में बात करेंगे, पूरी तरीके से समझेंगे कि 3D प्रिंटिंग टेक्नोलॉजी क्या है, कैसे इसको डेवलप किया गया है, कब से ये शुरू हुई और क्या इनोवेटिव तरीकों से ये लोगों की हेल्प कर रही है, कंपनीज, बिजनेसेस, इवन स्टूडेंट्स की और एनवायरनमेंट की ये टेक्नोलॉजी हेल्प कर रही है। तो आइए शुरू करते हैं। All right, so today we have Mr. Parth Agarwal with us, and Parth is the founder of Sarg. It's a company which is developing 3D technology, 3D printing technology, and like they are using it amazingly for giving a lot of solutions to the market. So, Parth, welcome to the IFW show. It's great to have you over here.
Thank you so much, sir. It's a pleasure. Thank you so much.
So I would just like to just say that 3D printing इस पे हम बहुत डिटेल में तो आज बात करने ही वाले हैं आने वाले पूरे एक 45 मिनट्स के ड्यूरेशन पे. Just wanted to know like how you came with the idea of getting involved into 3D printing technology. What ignited in your mind that this is something that you would like your career to be into, and how did you start this company Sarga, and you came up with this interesting name for Sarga also. So what has been the journey? How did you start, and how are things looking right now in this technology and in your company right now?
Right. So, sir, like the thing that when we went into it, like this was something quite accidental. It wasn't planned. Like, okay, we have to start this at this particular year. So, like we were all usual. Like we are three co-founders, and we were usually back in our workplaces. I was working as a geophysicist in an oil exploration company. My other two co-founders, Rahul Pandey, he was working as a senior product manager in Simons, and Rishabh Shah was in a telecom company. So we usually meet in whatever holidays possible. We are all college mates. So my working was like 3 months work and 1 month off. So usually my off time, I visit my friend's place, and so we were just talking about technologies changing the world. And that particular conversation about the technology changing the world is made us the company that we are today. So this was the basically journey, and then we were like fascinated with these technologies, that the sort of impact that they were creating around the world. So why not we also educate our people about these technologies at an early age? We usually stay, a step behind mostly with all the developed countries. So we thought that why not push it in at an early stage, and why not take advantage and tell people about taking advantage about it. So we started off with the education sector, and we are introducing these technologies in the schools and colleges right now. About the company's name, Sarg. So Sarg is something sort of a very uncommon name that usually people come across. Even people are like unable to pronounce it. They're like Sarga. So we are like quite familiar with. We have to get acquainted to people accordingly. So this is basically a Sanskrit word which means rachna and creation in English. So as we know, 3D printing has the capability to make anything literally. So that is why we came up with this word Sarg. And this also has a notion of keeping our culture together. Sanskrit is something that we are culturally bound with. So that was also another motive behind keeping up this name. And currently, like we are like yes, we are working strongly in the education sector, continuously moving to introduce these things. We are also expanding our horizons to other technologies. We are bringing in IoT, robotics, AI, ML, and we are working continuously on bringing up new technologies with us. So this is how we are growing, and we are also giving marketing solutions to people wherein how they can benefit from 3D printing industries. And in our upcoming presentation, I'm sure I'll be able to explain about how people are actually utilizing it with us.
Fantastic. So it's an amazing story. I'm sure that in the years to come, that we all will be talking about Sarg and your initial startup with your two co-founders. Just like we do, these days talk about big companies who started from a garage room or maybe started with some college friends together, coming together, and they made up great companies and big companies name for themselves. So all the best to you guys. So you are doing amazing job, and adopting something challenging and a very new technology is very amazing, because normally people can play safe in the market, but to adopt a new technology, a new trend, and developing it as it is getting developed all over the world is an amazing challenge that you are taking, and it's fantastic to listen to that. So this was about Sir, this was about your startup. Now let's talk about the actual technology of 3D printing. So Parth, it's over to you now. So tell me how you would like to tell our audience and explain our audience about this technology and its entire applications and know-how today.
So right, so let us start with the presentation that we have here. So please display the presentation so we
Right.
can
So
view it.
I'm sharing the presentation to everybody. All right. So we
Yeah,
can see the presentation now.
yeah. So the next slide, sir, please. So 3D printing is a technology with which we can actually convert any digital file into a three-dimensional physical object. So when I talk about a digital file, it is anything like that we can design into our CAD softwares. A very usual example that even a layman has come across is like architects design, the houses in the software. So वो जो designs करते हैं एक 3 dimensional axis के अंदर में हम when we feed it into a 3D printer actually makes that physical object in whatever size we have given the input into. To explain it in a much better way, we have a picture here of a bowl. बोल के ऊपर में कुछ layers हैं that is defined quite clearly. So 3D printing is a nickname. It is actually called additive manufacturing. So additive manufacturing is quite clear with its name, like it adds and then it makes something. So the layers here depict something like 3D printing works by adding layer upon layer and then it makes anything. So we all have seen the mehendi ka cone hota hai, right? We press it and it starts putting out the layers in our hand. So a similar way, nozzle of a 3D printer works. Just in place of जो मेहंदी निकलती है उसकी जगह पे it extrudes out molten plastic. So it lays down single layer on the build platform, then the build platform moves a bit down, and then another layer of extruded molten plastic is laid upon the previous layer. So this is how layer upon layer it builds anything as per the instructions given to the printer. So this is something which is not new. It is something which has been discovered and invented back 40 years back in 1980s. But it is we were not aware about this technology it was already working around the world and is has grown a lot from its infancy in 1980s to now 2020.
Right.
So let us
Amazing.
understand about
Yeah,
yes.
I just sorry to interrupt you. Just wanted to say the audience that if they have any questions in between, because this is going to be a very interesting live session. So you any question do you have in your mind related to 3D printing, its technical part or maybe its application or usage in daily life, how it can be used, you can put it in your comments wherever you are seeing this video right now, either on YouTube or on Facebook. So we would love to take your live questions also in between or maybe at the end of the session. So just wanted to say that to all the audience watching. Parth, please carry on.
Right. So to understand this particular process in more detail, let us move on to the next slide. So this is the complete process of the 3D printer. This is a fundamental process. This is a bedrock of the 3D printing industry, regardless whatever technology we are utilizing it. So in order to work in the 3D printing, you need to have a CAD file. So the CAD file is a digital file that you can either design in a software or you can download it from n number of freeware websites that are available. So once you have the CAD file, then you move your CAD file into a slicer software. So the slicer software is a bridge between your design and your 3D printer. It converts the file into a language which the 3D printer can understand to make it more simple. हमें पता है कि जो हमारे computers होते हैं वो binary language को understand करते हैं, 0 and 1. Similarly, 3D printer understands G code. So the slicer actually converts the design file into G code, which the 3D printer can understand. And it has a much more important function, that it slices the file down into small layers. So as I mentioned in my previous slide, that 3D printing works layer upon layer. So in order to work on one layer, then another layer, it needs to know which layer to work first, how much to work on it, with what speed, with what temperature, with what dimensions. So this is what a slicer software does. It slices the files down into small, and it is in the flow chart, you can see the file, the pyramid has been sliced down. So once you have the sliced file ready, then with the help of a pen drives or Wi-Fi connection or SD card, you place it into the 3D printer, you load the file into the 3D printer, and then you just give it the print command. Nozzle starts working, as per the G codes fed into the 3D printer. And then finally you have the complete design file in front of you. Now that is not the place where the work is over. Once you have the design file, it requires a bit of the post processing, to make it aesthetically look good, like basic sanding, spray painting, and all, whatever color you need it in, some sorts of basic thing. So guys, this is something which is the fundamental, as I mentioned earlier. This is the bedrock. Whatever technology you're working on, this is something, this is the process that remains. This is the bedrock, this is the fundamental. So now we've been understand about what other technologies are there in this ecosystem.
Great,
Next slide,
great,
please.
fantastic. So, Parth, just a small thing, like what I am trying able to understand is that just like a architect, when he plans a building, or they use the AutoCAD software to plan the elevation and everything about that particular building. I guess in similar way, like if you want to create a product or a object, basically, so you can create a CAD file, plan the whole thing, and then just give that command to the printer machine, and which will create that thing for you, right? I guess it is something like that.
Exactly, sir. Exactly. It is exactly like that. Like you can create, you see, you just have to know what you have to make and it will make it for you. There is like no limitations. Even we have started using 3D printing in our daily life. I'll just show you a small example here. So you see, this is, I guess everyone is able to see, this is a small keychain come phone stand. This is a small keychain come phone stand. So which I usually use in my office to play videos, or say maybe if I'm on a call or something. So, and this is something quite cool, and this is something which students can easily design. So we are actually empowering people to make things happen, to make things, to know the fun behind making things. We have never felt it. We have a consumer mindset. We don't have a maker mindset. So we need that revolution, that passion in us, that yes, we can also make things. That is the reason that we don't have innovations. We don't have people coming out with new things. So we have to change the mindset.
Fantastic. Yeah, amazing. So we'll move to the next slide, Parth. Yeah.
Right. So this slide is basically focused on the technologies, the major technologies that are actually around in the ecosystem. So we have first with the stereolithography. This is a 3D printing technology. This was the first technology which was invented in 1980s, and then other technologies came in. It basically, the difference between all the technologies is about the energy source and the material that they utilize. So here, stereolithography and digital light processing utilizes resin. This is a liquid material. Over the right-hand side picture, you can see a container with a liquid material. So this is a photopolymer, which when interacted with UV light, it starts hardening up, and it actually gives out the material. Then we have selective laser sintering. This technology is something which is not in the reach of common men. This is something which starts from 1 crore plus technologies, and it uses powdered material. Powdered material as in powder of metals, gold, silver, aluminium, SS. And then we also have some other tech, like other powders like ceramic and all. So it utilizes a high powered laser with which it melts and binds that particular powdered material together.
Right.
And then we have binder jetting. Binder is again similar to SLS technology. It also has powdered material. However, to bind those powder materials together, it utilizes a chemical, binder chemical. which when sprayed over the powdered bed, the material come together to fuse together to form anything. And then we have fused deposition modeling, FDM technology. This is something which is the most popular, the most used, and one of the most affordable technologies that people are adopting quite easily. And about FDM printers, we have some upcoming slides. We can move to the next slide to understand about it better through a schematic. So this is basically about a schematic of an FDM printer. Over the left hand side top, you have the material spool. So the material in FDM printer is usually in the form of wires. This is like 1.75 mm wire, and which with the help of an extruder motor goes into the heated extrusion head. This is basically the nozzle, heated extrusion head, which is actually heated to about 200 degrees Celsius. So when the wire moves inside the nozzle, it comes out into molten form, and then you have the build platform below where you are seeing a cartoon character. So as per the instructions, it moves around the build platform layer upon layer to make anything. So this is the basic functioning of an FDM printer. And so over the next slide, we also have a exact 3D printer machine wherein you can understand about the parts. So we'll start from the right hand side bottom. So we have the print bed, you call it print bed, you call it build platform. Ultimately, this is something where anything, the printer makes anything. This is the platform where the nozzle moves around. Then above you have the yellow colored filament, the 3D printer feedstock, which goes through the extruder into the nozzle. So extruder is basically a motor which actually pushes the filament inside the heated nozzle. And once it pushes it in, it comes out in molten form. And over the left hand side top, you have the printer display. This is the control screen of the printer, wherein you feed the designs, you give it the instructions to print, how much temperature you want to print it in, and all sorts of things.
Right.
So this is all about
this yellow color filament that I can see in the form of wires in this particular diagram in the photograph. This is the material basically which is used to form that particular object that we are creating. So I just wanted to know, like, if can we have like different kind of metals also used as the material to create some kind of object?
Yes, exactly, sir. You can print in metals as well, but not with FDM technology. So FDM is something which is limited to only plastic materials and some composite materials.
Okay. Great.
Hello. Am I audible, sir?
Yes, we are very clearly audible. No problem.
Right. So in this FDM, we are limited to only plastic material and some composite material. And about the materials, I'll just brief it in over the next slide.
Sure.
So this is the range of basically materials that we have here. So PLA is polylactic acid. This is the most utilized material in FDM printing. So PLA is something which is environmental friendly. This is biodegradable material. This is developed by processing corn starch, जो भुट्टे का कचरा जब हम लोग इकट्ठा करते हैं खेतों से, उसको प्रोसेस करके इस वायर फॉर्म के अंदर में कन्वर्ट करा जाता है. This was actually developed for the education sector because it has strength as well, and when used in the education sector, when the plastic melts, it does not create any fumes which are harmful for the students and people studying around it. So this is something was developed. Then we have some engineered plastic like ABS, nylon, PETG, TPU, PC. These all are used as per the properties and the functioning of the prototype that is required in the market. And this is the basic list of the most used materials. However, this is not an exhaustive list of materials. We have materials like in wood fill. Wood fill is again, it is something, a mix of a plastic and wood components. So when the finished material is received in hands, it actually looks like it is printed in wood. However, it is a plastic material. Then we have marbles and, just to give it an good aesthetic look in particular wood finish or marble finish. So we have n number of categories in it. And if we talk about other technologies like SLS that we studied about, the major industrial technologies, they can actually print metals, metal parts and all. And these things are actually being utilized in the industrial sector, actual practical application, not just limited to prototypes. And about these we'll be discussing in detail in upcoming slides. So this was all about basically 3D printing technology working in this ecosystem, in this space, how things are used. Now, to understand it more in detail, that how did it come this particular way, let us dive a bit into the history of 3D printing. So next slide, please. So 3D printing, as I mentioned earlier, it is not something which is very new. This was something which was discovered, invented in 1980s by Mr. Chuck Hull. Amazing person. Like he came up with such a beautiful idea of discovering this thing. And in 1980s, it was developed. It came up with the mindset of creating prototypes just so we can see what we are thinking, what we are imagining. So in 1980s to 2000, it did not receive much utilization because it was limited. It was limited by the cost. The cost factor was quite high. So not high adoption was seen. Only some major industrial players were able to work around it, and so not much of the applications came up. But something amazing happened in somewhere around 2004 when an organization named RapRap came in front.
Okay.
So RapRap was an organization which actually made 3D printer accessible to common men. So what they did was they developed a 3D printer and they made it open source to everyone. So if just to the audience who are not aware about what open source is something which आपने कुछ भी file या कुछ भी object आपने develop करा and you made it open for the public for access so that even they can develop it, they can work on it, they can make it better. So that particular product does not goes through the development and refinement by a single person or a single organization. The whole community, the whole world can work to make that particular thing better and better and better in coming years. So that is something amazing that RapRap actually did, and so it was accessible to everyone. They can actually make things. They can make a 3D printer in their house, but that was not the only motive with which RapRap worked. So RapRap had a notion of if you have a 3D printer, you can actually make one for your friend. I repeat, if you have a 3D printer, you can make one for your friend. You see, this is something amazing. And how this was possible? Because majority of the parts in RapRap's 3D printer were 3D printed. So you can 3D print majority, 90% of the parts, and some you can buy in your local pawn shops or from anywhere. So that was something which led to the major adoption in 2004 and into the coming years. That was when major makers, major innovators, major hobbyists started utilizing it. Companies started showing interest in this technology. So that was the point where the 3D printing revolution came in. That was the point. And then the research started. Then now you can see there are n number of industries that are utilizing it. You call it from aviation, automobiles, aerospace, and even like other manufacturing industries. All are into it. All are into it. So this was the whole gist and
Yeah, this is
about.
fantastic. So, like, I was just while listening to your this particular slide, I was just imagining like the ease with which we print documents these days. Right, we can send a document to somebody and they can print a copy of that
Yes, exactly.
with the same ease. If let's say we want to send an object to somebody, we can just share the file of that whole design and concept to somebody else, and they can use a printer for that and print it again. So how easily one object can be transferred in a way to somebody else.
Exactly. You see now, this is something which is leading to a time of localizing the manufacturing part. So we are actually able to we are able to localize manufacturing now. We don't need things being assembled somewhere else and then being shipped to us. We can actually make things in house in our city locally. This is the power of it. So to understand about how is the power, how are the applications around, let us now understand some applications behind it. So please, the first one, next slide, please. So prototyping and manufacturing. This is the major industry that was impacted initially. So a small question from you, sir. Like, say, if you come across a thought that, say, I'm taking an example of a bottle, that this is something or you always see bottles are like this. What if a thought comes into your mind that no, bottles are not to be designed like this. I have a more efficient design which can be tested, tried, and iterated, and then we can make bottles in that particular design. So, who can you approach? Like, say, a manufacturer, or who can you approach to?
Yeah, so I'll have to basically contact a manufacturer only because I would not be able to like design it myself. So I'll have to go to a manufacturing unit who can develop it, and obviously it will be a very costly affair because they will only accept it if it's like a very big bulk order that I am giving to them to develop something like this.
Exactly. So these terms before 3D printing, it actually involved a lot of cost. Like it was not easy for any person to just take his design and manufacture it and see it. But 3D printing came in with a big help to such people. If you have an idea, you can 3D print it in like few bucks, like few hundred rupees or maybe like few thousand rupees. You have it ready, you test it whether the design is working or not, and then with 100% surety based upon the customer feedback, based upon the usage, you take it to the manufacturer and launch it in the market. So you have a much higher percentage of success rate to launch a product in the market. So that is where prototyping and manufacturing, it changed the complete scenario now. You can actually first design, test, iterate it, make it market ready, and then you launch it in the market. So this is one of the major use that people need to understand, that this is a major revolution that 3D printing is bringing in.
Right. Of course.
Right. Yes. And moving on to the next slide. Aerospace industry, like an interesting place to work in. Like we have like important engineering aspects going it in and things. So this is a very big industry which is actually utilizing 3D printing to reduce its cost. Now let me tell you how they're actually reducing its cost. So over the right hand side, the rocket type picture that you have is basically the fuel nozzle inside the engine. So earlier with the traditional manufacturing, any fuel nozzle is actually have 32 different parts. So these 32 different parts have to be made together, joined together to make the nozzle happen. 3D printing is bringing a time of functional integration. So, excuse me. So functional integration is a time is a concept with which you actually integrate multiple assemblies function into one single product. Like say if 32 parts are working different functions, giving different inputs into the whole assembly, that all 32 functions will be embedded into a single product. It would be single, there is no assembly required. So you reduce the workforce behind it, you reduce the logistics, you reduce the time, you reduce the weight, and there are n number of things, material wastage and everything. So this is a bit technical part, but this is a huge point for the aerospace industry to utilize, and they are exploiting it like anything. They have like they are saving millions of dollars over it, and they are even now started to 3D print aerospace engines. Even Boeing have 3D printed engine, and they have tested it. A plane is flying with a 3D printed metal engine.
Amazing.
Yeah.
Fantastic.
So let us move on to the next slide. Dental industry. So there is quite a big line that goes around in the 3D printing industry. Like 3D printing is bringing a time of is taking the industries from mass production to mass customization. So we need customized solution now. There are some upcoming slides where I'll tell you about customization. So this is a big example that we can start with. So we usually have like dentures and cavities and everything around us. So the usual traditional process starts with modeling our teeth with clay and then taking it out, and even there are n number of inaccuracies that actually takes in a long process, like a week's days process. But with 3D printing, whatever you can scan your complete jaw. Once you have scanned it, you design based upon the scanned data. You don't need to design anything. You just take out that particular teeth, and whatever the root canal or the dentures need to be revolved around it, exactly fit specifically your teeth with 0% error. The 3D printer is able to design customized things for the patients, and this is even being utilized in the dentals now. Many dentists in metro cities in India, they have started utilizing these things. Specific customized solution. Yeah, the cost is a bit higher these days, but yes, definitely there is again the failures cost is reduced. It's much more comfortable, and some other things as well.
So here you mentioned about the scanning part of it. So just like
Yes.
I wanted to know that the scanning is possible without the printer also, right? So every doctor, if he is using it, he can use the scanner only also.
Exactly. So scanner is just to take the images, to take the dimensions inside your jaw. So once that is done, if he does not have access to a 3D printer, he can share it with some of the service providers, and they can make the solution, everything, and then ship it back to the doctor.
Wow, fantastic! That's interesting.
Yeah. So please, let's just move on to the next slide. So food, this is something, a very interesting industry, we know, and quite growing industry in the upcoming time. So 3D printing, with 3D printing, we are actually, able to 3D print food now. So the technical aspect I'll bring in later. It is about the shapes. You can explore n number of shapes. So to bring it in, a restaurant in Spain named Food Inc. has taken this initiative, and they serve all the 3D printed foods. Only 3D
Wow.
printed food, that's all. You have to select the shape, whatever you have to eat, and that particular shape they serve it. So this is something which is start of something amazing. Apart from it, it also has some of the specific technical aspect. Like, since we have, every one of us has sort of different anatomy, different diet structure, different intaking of the nutrients. So 3D printing in food is being researched about setting your diet specific to nutrients and
Mm-hmm.
vitamins, how much you need. So your particular diet and that particular food will be made with specific amount of nutrients, with specific amount of vitamins. So this is
Wow.
something which can be quite revolutionary in removing malnutritions in underdeveloped countries.
Wow. Interesting. Interesting.
Yes. Moving on to the next slide. Then footwear industry, again, one of the major industries in the complete world. Major companies like Nike, Adidas, they're actually utilizing 3D printing technology to make shoes now. So again, as I spoke about, we all have customized needs. We all have a different anatomy. So हमारा जो पैर का size होता है, like in market we have standard shoe sizes ranging from 2, 3, 4, 5 up till 10, 12, 14, whatever it is. These are like standard sizes that are available. Say हमारा पैर का size maybe like 9.5 है, 9.7 है. So we are stuck with to wear the size of 10. And such improper shoe sizes actually leads to many of the foot problems like flat foot, arthritis, sole problems and all. Then we wear some specialized insoles given by suggested by the doctors. So now we can actually scan our foot and make a shoe specific to our foot, it's only to our foot only, specific to your foot.
Wow.
So this is something which is quite amazing. This has enabled companies like these Adidas, Nike to reduce the stock amount that they usually keep in their warehouses. Now you don't need to make like manufacture like lakhs of shoes of one single design. They have changed their working. They're only making like 10,000, 5,000 pieces of single design, and that is all. They move on to the next design. Limitedness. So this has reduced their investment of capital in their work as well. This has made them, much more comfortable. And with the help of 3D printing, they can reduce their logistics amount. They can localize manufacturing in wherever they have the presence in all. And this is again a big example, like as you said, that we can just share the file and we can make anything anywhere. So this is a good example of localizing the manufacturing. Even about this part, there is a news going around in the industry these days. Like now, Amazon vans will be roaming around in the city with 3D printers in the van. You order
Wow.
anything, and they will make it in the van, and then they will give it to you.
Oh, that's amazing. That's
So
amazing.
this is,
So
yeah,
I was also thinking that like people who have special needs, like especially from the medical perspective, that people need special shoes, special things designed as per their medical needs, or they have some deformity in their feet or body parts, so they can use these things very easily, I guess.
definitely, sir. And even many of the assistive devices that are actually were not available now are actually being made with the help of 3D printing. Like this is something where everyone can make anything. Imagine a time where, say, everyone is a problem solver. We have many problems in the community. So imagine a time where everyone, even you and me, are solving at least one problem that is around the world. So how many problems will you be able to address? So this is the power of making things. This is the power when you have a maker mindset, apart not the consumer mindset.
Amazing, amazing.
Right. So let's move on to the next slide. Then again, eyewear. Again, this is again one of the major industries. So the frames is basically like these are like plastics. We all use eyewears. So yes, we know these can be 3D printed easily in some technologies and all. But when we talk about the lenses part, so even the lenses are being 3D printed. And ophthalmic lenses, which is specific to the prescribed number of the person, That can be 3D printed with the help of the resin technology that I talked about earlier. So
Okay.
now, why not go with the traditional manufacturing, and why are we going with 3D printing? Let me explain it here. So the traditional manufacturing, when I talk about, it's usually like subtractive manufacturing. So you have something big and then you cut it out from that. We are cutting it out. There are like machining, tooling part involved in all it all. So there is about 80% of the material that goes to waste. We cannot utilize it once it like cut and all. There's a lot of wastage. But when we talk about 3D printing additive manufacturing, as I explained earlier, it adds things layer upon layer, layer upon layer. So there is not something like cutting out anything out of anything or all. So this is something you see, it saves a lot of cost. It saves a lot of cost. It is giving you customized solutions. And with this, a company named Luxcell, this is a company in Germany. This is actually utilizing it to make smart eyewears. When I talk about smart eyewear, it is like you tap the lens and it will change the color to adapt to the light. Say you are going out, you tapped it, it will convert into the sunglasses. You tapped it, it converts into a normal eye lens. So this is the era this is bringing in.
Great, great, amazing, amazing. So that this is very interesting. So we have a live question by somebody. I'll just put it on the screen. I guess this is related to the costing part of a 3D printer. It says, what is the average cost that a 3D printer can be procured at? So I guess this question is directed towards what is the starting range of a 3D printer if somebody wants to procure it for their use. Because I'm sure that it can go very high also as per the nature of usage. So just can you just give an idea of like what can be a starting price of a 3D printer?
So yes, so FDM printers, as I mentioned earlier, are one of the most affordable 3D printers in the market. So they range from like starting from 18-20,000 now in the market. These are like DIY printers, which you get, you can assemble it, you can purchase it from Amazon and from any other online websites. And so you just have to assemble the printer as per the instructions. This is not a big deal. So these printers usually start from 18-20,000. But if I talk about some good printers ranging, so this is somewhere around, let's say 30-35,000, you get a good printer. At least for the hobbyist, they can utilize it from 18 to 35,000. They'll get a good printer to work on, to
Oh,
explore
fantastic!
the.
That's quite reasonable. Like I was thinking that it would must be starting from at least a lakh or something.
No, 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 no. That is what the rap is bought in. You see, like accessibility. They have made it accessible to everyone. If a person is willing, there are even n number of open source, designs available. A person with a good technical know-how can actually, go to have the files. BOMs are there, the bill of materials of all the dimensions and everything. So with the help of some local, people, machinists and everyone, he can actually make his own customized 3D printer also.
Fantastic, fantastic, great. That's great.
So next slide, please. So medical industry. So medical industry is one of the other industries that have actually adapted 3D printing for the betterment of the public and the community. So this is something which is utilized for pre-surgical planning. So when I talk about pre-surgical planning, it is something, say a major severe accident has happened and a person has like in the left hand side picture, you see the elbow model printed. So this particular patient has had a severe damage in an accident in his elbow. So earlier, what was like, we used to scan. We had doctors used to have an X-ray. Based upon the X-ray images and all, they conducted the operation. But X-ray, again, it was 2D. Like, it did not give much of the details about the injury. So always it was a surprise for the doctors whenever they operated the patient. They have in the X-ray, they might see the condition of the bone and the fragments that are lying here and there, but the muscles are, again, damaged to a great extent. So with the help of 3D printing, you can actually use these X-rays and CT scans and everything to make an exact 3D model of the damaged bone. You 3D print it, and doctors can actually have discussions on table to see how are they actually going to align these bones together, these parts together. So success rate in an operation theater is much higher. The risk to the patient's life is much higher, and the time over the operation theater's table is quite low. Moreover, again, there is another thing of communicating the patient's condition to the family or even to the patient. So if the patient and they are able to understand, okay, this is what has happened to us. So this has made medical injuries and medical terminologies much more understandable to a layman, wherein like we usually have a behavior like, okay, yeah, this is something which is way out of our league, we cannot understand it. But 3D printing and such technologies coming in around, we there is a better communication between both the parties. They're able to tell something, so we have a sort of a satisfaction inside us. Okay, we know things. This is how they are going to take it, and this is how I'm going to get on with it.
Amazing, amazing. So that's an amazing application. So, Parth, we have a lot of audience interesting feedback coming up and questions coming up in the live session. Mr. Dhruv says 3D printing is the future, and I have one more question that I would like to take up right now only. That do 3D printer require servicing? If yes, how much money do I require, and how often do I have to service? So, I guess Mr. Kaushal is about to plan a 3D printer for his requirements. So, what would you suggest to him?
So say a 3D printer requires servicing. So 3D printers are like something which is like the least. It requires very least service, like over like 2 or 3 months. You just need to do basic oiling around it, and that is all. This is all, and your 3D printer is good to go. There are like few things that you need to usually follow, like using good materials so that the nozzle does not get much of the abrasion and all, and rest good amount of oiling. This is all, and then you are good to go. This is all. So it is like the after the procurement part, 3D printing is quite cheap. It is not something which comes along with a lot of cost, a lot of burden overview. Moreover, even the electrical consumption of a 3D printer is very, very, very low, very low.
Fantastic, fantastic. Great, great. So, Parth, let's move to the next slide. Yep.
Right. This is again something which is a future. Like a person like Dhruv Shah, he mentioned about 3D printing is a future. So yes, it is. So bioprinting is something which is a completely different dimension. Bioprinting is bringing a time wherein we'll be able to extend our lifespans. We'll be able to expand our lifespans. And how? So with 3D printing technologies, we are actually able to make functional organs happen. Functional organs, like will be able to print kidneys, we'll be able to print hearts, and all the things like that we usually need, like जहाँ पे हमको donors की जरूरत पड़ती है, we lose many people because of it, because there is no availability out there. So this is wherein we are printing cells. We are actually printing cells even for the wars wherein our soldiers get injured. So skin tissues are being printed so that their injuries can be cured at the earliest, quite quick, and such things are happening.
This is a revolutionary part. I was not aware of that. This technology can go into this depth and for these kind of things. Amazing.
Yes, so you see, this is something actually the future. A lot of investment and a lot of research is being going around, even in India and in abroad. A lot of research. Even one of my friend, he's working into it right now. So he tells me like this is something like they come across a lot of failure, but this is promising. This is something which is actually going to happen in near future and quite soon. So let us move to the next slide, please. And then usually like jewelries again. So printers can be used to print minute designs and customize jewelry. Say a person just want to make a corporate gifting out there, and he wants a coin with his company's name, a gold coin, say, with his company's name and a logo, or maybe his own picture. So going for a mass manufacturing, going for a mold manufacturing is quite expensive. So he can actually 3D print it either, or can create rubber molds with the help of 3D printers, and can customize jewelries specifically for him, like one piece or say 100 pieces. And then over the right hand side, we are all into Hollywood movies these days. So like the Iron Man suit, it was 3D printed. The Queen Amanda's costume that you see here from the Black Panther movie, this was 3D printed. And you can actually make costumes. Even I have a small example here with me. So this is a fabric, and these are like dragon scales. Everything one see it, right? So this is what the power of 3D printing is. You can actually make things happen over the fabric as well. So this is how things are being used in the costume and the Hollywood industries. Even many of the cars that we see in James Bond and all, many of the parts of these things are also 3D printed. So a quite different era.
Fantastic. So, Parth, we have one more question. This is by Dr. Ramesh Pandey. So, he asked 3D printing a great initiative, so many applications, but I have a doubt how much time does it take to print a model, a normal bottle? If I say if you can give some example of it.
Right. So again, a good question from Dr. Ramesh Pandey. So this is I believe for specifically for the FDM technology, that is something affordable and accessible to the people. It is something which is time taking. Say if I talk about a bottle this size, it would I guess takes about like 7 to 8 hours to make anything. So yeah, this is I believe something that it has a backdrop. But again, if I talk about the benefits that you can actually make things at your home, then I don't take it as a disadvantage of this technology. So yet, yes, it is time consuming. People are working over it. Even we are working over it. How we can reduce it? But if you talk about some industrial technologies that are working around it, these are like quite fast, like half the time what FDM printer utilizes.
Great. Fantastic. Fantastic.
Then something which I find quite amazing. 3D printing technology is actually being used to make houses, to make real houses that in which we can live in, and at a cost you cannot believe. Like with few bucks of the cost, like we can actually make a complete house for like 1 BHK, 2 BHK size of the house, and quite quicker. So what is the usual time, Karan sir? Like you believe that we a house 1 BHK house takes time to construct with our normal process.
Well, I can say it will take at least 2 months to 3 months to construct a 1 BHK also, because right from the foundation to everything, if I and all the interiors, elevations and everything, if you plan, then of course it will take at least 2 months.
No, more than 2 months. Like usually, whenever we plan a house, it actually goes from 6 months, one year, some
Yes,
sort.
that's it.
It
Yeah,
takes
minimum 2 months at least. Yeah.
Yes, exactly. But with 3D printing, like it's an overnight work. It's overnight work. It creates a complete house. The picture that you see over the left hand side is a 3D printed house in America. So they actually
Wow.
made it. This was the first prototype. So an organization named Wiki House has come forward to work on these printers, and they are also making it again open source. So so this is not something about making houses quicker and making construction cheaper. It has a different motive behind it. It has a different motive in making these houses quicker, making these houses cheaper. So we see a lot of disasters taking place in and around the world, wherein people are left homeless these days, and many of the people actually don't have home. They are quite poor and all. So organizations are coming forward to provide shelter to these people.
Wow.
So this is something which is quite useful in the disaster hit areas. You with like say a printer, you can make a colony in like a month. So people will actually have houses. They won't have to live in tents and all. So there are like n number of problems they face too. So refugees or disaster prone areas, we can actually give them a roof and a proper home to live in. Moreover, it was quite useful in the pandemic. China utilized it for creating isolation homes. Like say I think in the 10-15 days they created like a complete hospitals and many rooms and many things for many people, for lakhs of people. They were isolated and everything. So this was like only in 10 to 15 days. But with usual traditional process, it might have taken years. It might have literally taken years. But we, with this technology, we were able to finish it up in like few days, 2 weeks. So this
Great.
is the power they give us. So let us move on to the next slide. And 3D printing in space, this is something which is quite futuristic. We already know people like Elon Musk. They are actually working in moving the mankind to some different planet. So,
Mm.
but we know the environments out there are not suitable for people. Even if we plan a manned mission out there, we won't be able to survive much longer. Rest keeping apart, making a whole colonies and for all the people. So with the help of 3D printer robots, we'll be able to construct houses out there. Moreover, power supply would be a big challenge out there. So
Mhm.
3D printed batteries, a big amount of research is going on in this particular sector. So this is something which is quite futuristic and again quite promising. Like anything you can think of, like people like Elon Musk are actually making things. What was something a dream few years back is now a reality now, and quite fast.
Amazing.
And so this was all about the applications around the 3D printing and all. In this particular slide, I would like to bring forward about the response that we created, the difference that we created with the help of 3D printing in the time of COVID pandemic. So the first picture that you see is a COVID key. So the major objective behind designing COVID key was about to reduce the contact at public doors, at public places. So this is a keychain. Over the bottom, you can see a small hole wherein you can utilize it as a keychain. You can hold it as a gun to say open doors, to pick up poly bags and all, to not touch anything directly. So that was the major purpose behind it. This was a small, quite compact for your pocket. Then over the second, you have mask straps. So we all know we are all wearing masks from like past 6 months now. So the elastic in our masks usually create a lot of pain when we wear it or the back, and we wear it like casually for like 1 or 2 hours or so. But think about the doctors who have to wear it continuously for like 8 to 10 hours continuously into the COVID ward. They were facing a big problem because of it. So we came up with this particular design. Even like this was not our design. This was something created by someone else somewhere else in France or Italy, and he made it open source. So we utilized his design to make to benefit people here in Udaipur and wherever we were accessible. So this is again, this mask straps has actually hooks, so you don't need to clip the elastic at your ears. You can clip it in the hooks of this particular strap. Over the next, you have face shield. Face shield, I know everyone is quite familiar now. It is being utilized in airplanes, hospitals especially. So this was again initially 3D printed. We know like in high peak time during the April and May, all the logistics were cut down. Only few resources were available. So this was one of the major resources that doctors actually needed. So we set up a complete 3D printing farm in our own office. We took special permission from district administration. We collaborated with their help. Even Hindustan Zinc, help us fund this particular project for R&T Medical College, and we printed like 5,000-10,000 face shields and supplied it to the doctors out there in short span of time. And then over the last, we have a hand sanitizer dispenser. So alongside working on all these products, we also thought about working on some advanced technologies and all. So this was a sensor-based dispenser which senses your hand and drops out the sanitizer how much and however required.
Amazing. This is amazing that you have done. We have one more question for you. This is Rani is a school owner. She says, if I have to take a 3D printer for my school, so at a time, how many models can be printed? For example, can 2 models be printed at a time? So I guess she's a school owner. So what suggestion would you like to give her?
Right. So yes, like there. It's not like 2. You can even print 5 models. But again, a 3D printer is limited in its dimension. So usually, whatever printers like hobbyist or schools utilizes, they have a printer of like say 20 centimeter by 20 centimeter by 20 centimeter. So yeah, say for example, say you have a model of only 5 centimeters in all the complete dia. So you can print 4 in a row, 4 models together in a row. So yeah, multiple models can be printed together. But yes, there is a size limitation. The printer has a fixed build volume. So you have to take care of that particular build volume, and then you have to move forward.
Yeah, so I would just like to say to Shivani that keep watching the video till the end, because there may be many more interesting things that this presentation will have for you for the benefit of your school and your students. Yes, amazing. Parth, carry on, please.
Yeah, so let us move on to the next slide. So this was all about the products that we made, and now let us see about the product development. So how we actually developed a product out of something quite scratch to the product that we launched into the market. So please play the video, sir.
Yeah, sure. Amazing, amazing.
So
This
this
was
was
amazing.
product development cycle that we showcased in this particular video. So you saw how we took it from an ideation about from small drawing to a complete finished product that we launched in the market. So you have the flexibility about creating the prototypes, iterating it before going big into the market.
Great, great, great. Amazing. So we have one more live question by Swati. She says, is there any limit in the size of the model we can print, or there is no limit?
So yes, as I mentioned earlier, like the printer has a specific dimension about 20 centimeter by 20 centimeter. But again, I would say there is actually no limit. Say you want to print something 1 feet high, so you print it in small pieces. The maximum your printer can fit in one time. So 20 centimeters is the maximum. So you cut your 1 feet piece into 10 different sizes, and you print different parts, and then you combine them all together by a glue gun or say a Fevistick or anything. So there is actually no limit.
Fantastic, fantastic.
And then lastly, I would like to showcase the work that we did around. Because of the good work into the education sector in Rajasthan. So the team was awarded by Chief Minister of Rajasthan about the award for like top 50 startups working into the education sector. Then over the second picture, we have a picture of a maker space. So we actually collaborate with all sorts of educational institutions wherein they can actually give us some infrastructure and we can develop a maker space in these institutions. So maker space is a place wherein the student have access to all sorts of technologies and equipments like electronics, IoT, robotics, even 3D printers, wherein he can just go make anything, innovate anything. They have our trainers, courses, or everything to support him. Then the third is like we were in discussion with the US Embassy's chairperson, Mr. Brown. He visited our office regarding the skill development plans that we can collaborate with America and in his exchange student program and all. So we had a good discussion about these things, how India is going forward. And then over the bottom, we have 3D printed farm manipulatives. So these are like farm models which are actually printed to educate farmers about new upcoming tools in the farm industry. So over the corner you have an aloe vera gel extractor. Then in the bottom you have a newly designed plow, which is quite efficient while working in the farms. And then you have a hydroponic model wherein you can grow plants without soil. So this is something upcoming in agriculture sector. Then in the bottom middle, we have robotics work wherein we collaborated with an organization named Mire Robotics. So they work into the robotics sector. So we created 3D printed body cases for them. So this is like all family of small products, and these all come together to make a robot. So you have motor, you have brains, you have ultrasonic sensors in shape of the eyes, then you have some touch sensors and all. And then over the last, we worked with a blind school in Udaipur, wherein we like these people do not have access to much of the educational tools. They are quite limited in resources and things which are available to them to make them education available and accessible in complete full. So what we did was we 3D printed alphabets manipulatives so that they can learn alphabets. So there is a small video that let us play to make the audience understand about what I'm talking here.
Sure, sure.
Come together along with you have a shape as well. So we know these people cannot see. So how do they analyze the shape? We remember anything with the help of the shape. So when a particular alphabet comes together, a particular word comes together, duck. So it also comes along with a shape. So they can feel the shape. Okay, duck, they looks like this. So they are having multiple benefit with this. This is quite effective. We ran like sample project here. It was successful, and they are still using it. They're still using it. They haven't seen arrows, rockets, and all these things, but by they are learning things, they're learning about shapes, they're learning about words, they're learning about alphabets. There are a number of benefits with it.
Oh, fantastic.
Yeah.
Amazing.
So this was all about the work and everything. Any more questions from the audience? And even if you have any question, I would be happy to answer.
So this is amazing, Parth. I'm just blown away by the scale and the ideas that I have seen right now with the you, which can be done. I guess there are infinite possibilities of things that can be done with 3D printing technology. And I guess as the technology is growing, as the applications are growing, as I guess in the medical field, research is going on using this thing for creating different kind of body parts, like that can be like life changing for so many people who just
Yes.
have to face loss of life just because they are not able to find the correct donor, or a particular body part cannot be repaired in some way. So I guess this can be revolutionary in many ways, and especially for education sector. You just mentioned a wonderful example of how a blind child can feel from his or her hands the alphabets and the
Yes.
shape structures, and by using these technologies. So I guess there's enormous possibilities in the medical, in the educational field. I just saw a small video somewhere that some students were creating a small project using a 3D printing, and they created the a particular Statue of Liberty kind of structure. So the teacher was training them about the Statue of Liberty, and they used the 3D printer to print a Statue of Liberty, and the students were able to see how it was built from the basement to till the top. So the students, I'm sure that that kind of learning will be an enormous learning, because they will not forget about that particular the thing, and they will learn so much from that particular experience. So in a
Yes.
fun and enjoyment way, they can learn the formation of things in such a beautiful way. So it has enormous possibilities. I think there are some questions that we would like to take. There is one question from Sudha. I'm Hello Parth, I'm from Pune. If you have to buy a 3D printer for my school, so do I need a special training for it, or can I learn it myself? Nice question.
Yeah, this is quite simple. This is like any conventional printer that we have with us. So there is no major training involved. But again, yes, because this is something new, so you need to be briefed about what are the do's and what are the don'ts. For it, we have n number of resources to go along with. So you can just do it yourself. It is like plug and play. It is plug and play. It is that simple.
Great, great. That is a very nice question. Is it useful in house also?
Well, yes. Again, this is again something. It is a mini factory. You see, so people are. You can make anything. So say, in my terms, if I say I don't have a spoon in the house, so come on, let's 3D print it. Buy it from the market. So yes, it is whatever you can think of. People are making, like as I showed you about the key, the phone holder and the keychain. So you
Right,
make
right.
keychains as per design, as per customized design. You make phone holders. You make, say, something for your for your washrooms, bathroom holders, and such things. You don't need to buy things outside now. You can make things at your home as per the requirement, as per the infrastructure available to you. And again, it is not something that you need to know designing skills. This is something quite, you see, there is an exclusive free library of designs already available for free. There are like thingiverse, even we are working on such a library, and we'll be launching it for people. So you can go as per the categories mentioned, you just search it along, and you download the design and you print it. You don't need to know designing to use a 3D printer.
Right, right, right. So, Parth, this was an amazing session. I request all the audience members to contact Parth for knowing more about 3D printing and how you can use this technology. You can see on the screen the website of Sarga, the contact number of Parth, and you can search his company on social media below this video. Wherever you are watching this video, you must be watching it on Facebook or on YouTube. You will get the contact details to contact Parth and his company and his team to get more information about this technology and how you can change your life literally by using this kind of amazing innovative technology that we have now available with us. So thank you, Parth. This was an amazing session, and I was just amazed to see the interaction that the audience had with you. And I asked their questions, and you were so wonderful in replying them promptly. So this was amazing. Just wanted to know from your side your last statements on this particular session, and how was this your experience in this show?
So, first of all, I'm quite thankful for you giving me such an opportunity. It was a pleasure to be here, and it gave us a much more visibility. Moreover, we also keep on conducting such sessions because we need to educate people around us about the upcoming technologies, about how we can utilize these things. So it was a good platform to work alongside you, and I look forward to have more such good sessions with you.
Sure, sure, definitely, Parth. We will plan more on these kind of sessions in the future. So, thank you, Parth, for coming as a guest and as an expert on this topic in this IFW shows episode. And to all the audience members, every week at 8 p.m. Friday, we come on these live session shows, and we have an expert on a particular topic. And these are all wonderful sessions that we are conducting regularly since last many episodes we have done, and we are getting very good response from the audience. So I would like to thank the audience also who has shown so much of trust and interest in all these shows. And since these are available, videos available on YouTube and on Facebook, in future also, if you have any questions, you can drop them in the comments. You would like to take them up and give the answers on those questions, or maybe request our experts to reply on them, so that this knowledge sharing can grow after this live session also. And if you find anybody who can benefit from 3D printing, maybe in business, manufacturing, medical fields, or any education institution who would like to adopt a 3D printer system for promoting or educating the students, please share this video link with them also. So with this, we would like to end the show of today. Thank you so much for the participation. Thank you so much for watching this show. Thank you.